Troopers 2025. Security software is supposed to make us more safe, but what if it isn't? Yennev Nizri is talking about problems where this might not be the case with FortiNet.
Thank you. All right, good morning. Hello, everyone. Welcome to my talk, Caught in the FortiNet, Compromising Organizations Using Endpoint Protection. I'm Yaniv. I'm a vulnerability researcher at Sonar. And when I do vulnerability research, I prefer to focus on web and high-level code research. Now, our team at Sonar have, I'd say, three main purposes. First and foremost is PR. We write blog posts. We go to talks like we see here today. But we also improve our own products with our security expertise. And from time to time, we do internal security, whether it's our own products, but also third-party software that we use. Now, I'd be lying if I say I went into this research with any of those points in mind, because, in fact, we are customers of FortiNet. So it could have been relevant to all of them. But since we were customers of FortiNet, on my day-to-day job, I got constantly blocked by FortiNet. And by constantly, I mean all the time. Now, you can also blame the policies that we enforce and not only FortiNet themselves. But yeah, my idea going into this research was maybe, only maybe, if I manage to break this software and then I will scare off our IT department, they will just remove it from my computer and then I will not get blocked. All right, so with that in mind, I guess you don't need really introduction into FortiNet. It's the third largest IT security company in the world, so I guess we all heard of it. And they offer a wide variety of products. And by wide variety, I mean hardware, but software as well. And I mean a lot of fucking software. Even the AI lost count of how many software they have. And God knows how they're connected and working together. And it's such a mess. But today, we will only focus on two. First and foremost is FortiClient. So this one acts as their endpoint protection solution. It has many features, like application firewall, web filtering, VPN, and so on. And integrated with that is the endpoint management server, or EMS for short. Now, as the name suggests, this one just manages all the endpoints using FortiClient on an organization. And typically within an organization, it will look something like this, that you have one EMS that is managing multiple endpoints. Now, you can have multiple EMSs for like section of the organization, but yeah, regardless, it will look something like this. And it can be hosted on-premise by the organization, but also hosted on the cloud by Fortinet themselves. Now, I can start and explain some pros and cons from an attacker perspective that wants to compromise an organization to what attack first. But in fact, we will start from FortiClient because this is what was installed on my machine, so this is also my research path out of convenience. So starting with FortiClient, when I booted up and started researching it, at first I saw that it's an Electron-based UI, which is a framework that enables developers to write a native application, but in a web format. It also offers some additional capabilities that the browser cannot, for example, accessing files or executing code or whatever. And if we look historically, some common entry points within Electron exploitation is like in-app user input. So it could be emails if it's an email client, or messages if it's Slack, for example. But you can get creative as well. For example, you can have files as input if it's an IDE like Visual Studio Code. Additionally, there's also protocol handlers. Now, I knew for certain FortiClient had protocol handlers, because when we registered for the VPN, it's just like we saw many pop-ups window, and then it came back to the FortiClient and stuff like this. And protocol handler is basically a way that you can register protocol scheme in your operation system. Here you can see Electron provides like a nice API to do so. And once the user navigates to this specific scheme, it will basically know to open your application, and then you can do whatever application logic you want to do with that, with the URL that is being actually browsed to. Now, I was researching on macOS, and on macOS, you can very easily see what protocol scheme is being registered if you go to the info plist file. Here we can see we have the Fabric agent protocol scheme. Great. So we have an entry point. So let's look at the function that actually handles this navigation. And we can see here that we have 5 different application logics. And the first one is the actual one that was interesting. This handle EMS invite code. And if we go into that, it takes the invite code from parameter from the URL. It checks if it starts with an underscore, and then it goes ahead and registers on-premise, and if it doesn't have the underscore, it registers on cloud. Going the on-premise route, it just does a very simple string parsing with a colon, and then at the end, we end up with an IP, VDOM, and invitation code. And then afterwards, it will facilitate the connection to the EMS. Now, the IP can also be domain, just to note. And we can understand that this feature is just like to have a convenient way to connect to an EMS with a simple URL click. But from an attacker's perspective, it suddenly have a lot of red flags. Most primarily, what stopped FortiClient from connecting to my IP or to any IP on the internet? And the answer is nothing, absolutely nothing. Also, if you're also connected to a legitimate EMS, it will just ditch that connection and connect to whatever you just clicked on. Not only that, EMS can have a nice capability to have a password protect disconnect. So basically, a client that is connected to an EMS with this feature, they will be prompted with a password input when they try to disconnect. This is meant to safeguard user to not just disconnect. So even if you're connected to an EMS with this, and you click on a link, it will just ditch this connection and connect to whatever EMS you just clicked on, whatever link to point to an EMS. So that begs the question, can we act as malicious EMS? And if so, what can we do? So this is a whole new attack surface. But does that mean that we have RC as a service? Not so fast. An EMS does have some management capabilities. For example, installing a certificate. Those could be interesting for an attacker, but they are limited. You cannot execute arbitrary code. So from here, we actually need to find a vulnerability to actually run whatever we want on the endpoint. So, of course, the logical thing is to just spin up an EMS and see what we can do and maybe what features we can do and we can exploit further. And we found out that, okay, we select the client, you can scan vulnerabilities, you can patch vulnerabilities, and in the action there is something very interesting. This send message feature, which here you can send a plain text, but you can also send an HTML file as a message to the client. Now, of course, if you've researched Electron in the past, this is all the warning bells just like shine now, because we've seen a lot of times XSS turned into RCE. And actually, if you send an HTML, on the client side, it will open up a new window. And that new window is actually configured with a safer web preferences. So for example, it doesn't have node integration. So you don't have the Node.js API, which basically gives you RC. So it is even safer. And not only that, our content that we send is actually being stored locally in a file and is actually being referenced within a web view. And a web view is similar to an iframe, but it's actually rendered in a different process. So again, another safety mechanism here. So what did we have? We have a main window with all the vulnerable configuration, but then we have a new window that doesn't have node integration. It has context isolation. It does have a preload script. Maybe there's some exposed functions there that could be interesting, but it doesn't matter because our code is actually running within a web view that doesn't have access to this preload script. So we're quite limited, but maybe you've already noticed something interesting. Our web view is actually referencing a file. That means that we are running under the file protocol scheme, which, first of all, it means that we can create an iframe to a different file, and then we can see the content of it and leak it because of same origin policy. Now, I know the documentation of it is a bit ambiguous, whether a different file is same origin, but in the case of what we had, it does consider the same origin. All right, so arbitrary file read, fine, but it's not RCE. More interesting than that is not only our web view is running under the file protocol scheme, every other window was running under the file protocol scheme. So that means if we can get any sort of reference to a different window, we can access their JavaScript objects, and then we can maybe escape the web view. But we couldn't actually get any reference. There is no window top or parent because it's not an iframe. There is no window opener. We tried also some other mechanisms that are like shared between origin, maybe to escape some service workers, cookies, local storage. Nothing really made us able to escape this web view. But in local storage, there was something interesting, which is a local storage also shared by origin. And we can see here that there was this parameter that is called compliance storage map. And here we have less connected EMS, and then we have a code. Now, this code references the previous connected EMS. It's a code because cloud-based EMS is a code, but if it's on-premise, it will be an IP or domain. Cool. So we can save this for later. Now, you can think about it. If I send a victim a link and they connect it to my EMS, the less connected EMS will be the organization legitimate one. Very interesting. But still, we do not execute any code. So I was kind of stuck here. I didn't know how to escape this web view. So I went on to my colleagues and I explained to them, hey, listen, this is my case. Do you have any ideas? How can I escape it? And of course, the first thing that they ask, well, did you try to see what Chromium version you run? And I went ahead. I did Navigator user agent. And to my surprise, the Electron version was 11 and Chromium version 87, which is quite outdated. It's from 2020. And this Electron version was also before process sandboxing was enabled by default. Process sandboxing is just additional safeguard that means that if you compromise this process, you're still limited. You cannot access files or execute whatever you want. So you need additional vulnerability to actually execute arbitrary code. So it doesn't exist. Great. So all we need to do now is go ahead and find an end day. And we found this CVE to be relevant. This is a type confusion in V8 prior to Chromium 90. And this one happened since TurboFan, which is one of the V8 optimizing compilers, did a speculative optimization when it assumed that it's safe to convert a signed 32-bit integer to unsigned 32-bit integer, basically missing a speculation guard. And if you want like a deeper dive into the CVE, there is a very good root cause analysis blog by Sirius. You can go ahead and read it. But yeah, here is the actual POC of the code, of this vulnerability. And you can see that first when we run it, we get a specific output. Then we run it a lot of times, and making it hot, this function, then making it optimized. And then when we run it again, we get a different value. And this is happening basically because TurboFan speculates that this subtraction here is a signed 32-bit integer. But in fact, it's not. So we can change this POC just a little bit, and at the end, we will have an array with a length of -1, basically an out-of-band array. Now, we have this out-of-band array, but since we're running on the heap, we will need a page, memory page with a read-write-execute permission, and typically what we see in the V8 exploitation is that you need the arbitrary read and write primitive from this out-of-band array, need to find a page with those permissions, write your shellcode, and then control the program execution to execute your code. Now, the first one is all said and done. The POC already had those primitives. And the last 2 points are also supposed to be super easy because we can use WebAssembly, which offers us this memory page and also a very convenient way to execute code on this page. So we went ahead and to adapt the CVE to our case. The POC crashed our client, meaning that it's supposed to work. And then we adjust the hard-coded offsets, but it still crashed. And it crashed when we were trying to write the shellcode to this page, which is weird because even VMApp showed that this page has read, write, execute permissions. So it should be writable. Why did it crash? Apparently, this is a restriction that is called write XOR execute, which means that the memory page can be either writable or executable, but never both at the same time. And Apple enforces that on Intel-based Apple Mac OS by hardened runtime, but on Apple Silicon, it's even on the hardware level. But JIT compilers do frequently rely on memory to be both writable and executable. So of course, Apple is aware of this, and they introduced an API, which is per thread, that enables developers to toggle the page from writable to executable. So we can check if your application has this allow JIT entitlement, you can call this pthread JIT write protect NP, which basically toggles the page between writable and executable. And we can verify that we have it on our code signature. It's also very safe to assume that we have it because we are running JIT. And then we can get this function from the global offset table, and we just need to switch a little bit the POC to just switch the page to writable, write our exploit there, and then switch it back to executable. Great, so we have a working POC. Here I need to give like a kudos to my colleague. He's the one that actually made this POC work. And yeah, let's see the demo in the workings. Hopefully the live demo will work. So here I have a Forti client that is connected to this EMS. So this is a legitimate EMS. And here on the left, I have the V8 exploit. So you can see here the actual function, the actual exploit. And here on the bottom, I have this change of pages. We change it to writable, we write our shellcode, and then change it back to executable. So now we're going to run this malicious EMS. And now all the client needs to do is to visit a very convenient, very convincing phishing page. Just click on a link and open it. And now you can see that it just facilitates a new connection. And hopefully we will see a calculator. In 5 seconds, I promise you. There we go. Thank you. You can also see here that we extracted the previous connected EMS as I showed in the local storage. All right, let me just stop it so we don't get more calculators. Perfect. So what did we have until now? We have a client, an endpoint. We send them a link. They click on a link. They are connecting to malicious EMS. Sorry. They are being compromised, and then we can use this code that referenced the previous EMS to connect back to the legitimate EMS. So now we are essentially acting as malicious clients. Great. But before we get into what actually we can do here, we need to first understand how do they communicate. So between the Forti client and the EMS, they're communicating with a custom line-based protocol. And the client sends headers, which is key value pair separated with an equal sign, and a body, which contains a type, and also the data itself, which is also key value pair separated with a pipe. And it ends up the message with a specific sequence according to the type. Now the server, on the other hand, only sends a body with the type of what is being sent, and also the data, which is key value like we saw before. And when we look at the actual sequence of connections, of messages, at first we have a probe request. So this one is meant to verify that the server is actually an AMS and running also a compatible version. And second of all, we have a registration flow. Now these registration messages can happen multiple times up until the registration is actually valid. And within the registration, there are basically 3 types of authentication. The first one is none. Basically just goes ahead and connect. This is what we use in our malicious EMS. Second of all is local auth or LDAP. This will prompt the user with a simple user like username and password, and then it will facilitate the connection with those credentials. And the last but not least is SAML, which will open the IDP on the relevant IDP on the user browser, and then it will go through the single sign-on and open back Forti client with a specific auth token. Then it will take this token and register with the EMS. So when I said that I knew protocol handler exists, this is basically what I saw. It was a SAML authentication, and I saw the browser pop up, and then it come back to the Forti client. Okay. After the registration is complete, we have keep alive messages. This is how actually it maintains the connection. So every X amount of seconds, which is defined by the AMS, it will send a keep alive message. And in this keep alive message, the client can update some information. So for example, they have a new IP. But also the server uses those keep alive reply to request or to update some data to the client. So for example, sending a message happened in this keep alive reply. This is why we had to wait a bit. And also in this keep alive reply, they can request, I don't know, upload logs. Great. And we have one last type of message, which is called data upload. And this can follow a request from the server, for example, uploading logs. But it can also happen on demand if the client, let's say, updates a profile image. So it doesn't have to follow any request from the server. OK. And this message type and this data message looks very similar. You have also headers and data. But you have, most importantly, a header that is a type, which is an enum, to what kind of data is being sent. And we noticed that there are certain data types that are being saved as file on the EMS. And they are being saved in the FCT upload folder, and with a specific file name format. You can see sometimes you have UID, host name, also provided type and hash. The interesting point here is actually UID is something that the client controls when they register, also the host name. And on the data message, they control the provided type and also the hash. Now, of course, also the file content itself. This is what is being saved. This is the actual data. So we can control the file content and also part of the file names. That begs the question, well, can we traverse back? And the answer is, of course, yes. So we have arbitrary file weight, but it's limited. We cannot control the extension of the files, and also sometimes we cannot control the suffix of the file name. So we were kind of stuck here as well because we couldn't make this primitive code execution. And then we went back to the EMS just to see what's up. And we found this interesting function that is called switch EMS, switch by IP. Apparently, you can, as an EMS administrator, tell a client, hey, go ahead and facilitate a connection to another new EMS. And on the client, it will just happen automatically. You will not see anything. You will not need to accept anything. So this means that even XSS here will be very impactful. So basically, if we have an XSS, we can make all the connections of the EMS connecting to a malicious EMS, like another one. And then we can basically use the previous vulnerability to compromise every endpoint within the organization. Cool. But can we make this limited path traversal in XSS? So we were running the Linux version, which is actually using the Apache HTTPD server. Now, by default, this server uses the modmine component to sniff the content type of the file by the extension. And I already covered like a small technique that if you don't control the extension, and you can have no name or only dots as name, and then it will basically send the file without any content type, and then the browser will sniff and guess the content type by the content itself and not by the file name. And then you can have an XSS, but it doesn't matter, because here we are configured with a no sniff header, basically meaning that the browser will never try to guess the content type, and then it will default to text plain. So again, we were kind of stuck, and then we opened up the documentation of modmine, and actually you don't need to scroll much to find this very interesting feature. Files can have multiple extensions, apparently, and if you have some extension that correlates to different content type, it will take priority of the last one. So filename.html will correspond to text HTML. GIF will be image GIF. .gif.html will correspond to HTML. But then if we have an unknown file type that doesn't correspond to any content type, we can add the HTML even after, but after and even before, and then it will correlate to text/HTML. Great. So we can take a file type that has unknown file type, unknown content type, and then we traverse back to the static folder. We just add a .html, and then we have an XSS. So let's see it working. So let's first connect to the legitimate EMS. Here you can see that I don't have this XSS here. So I'm just going to act as the client. So this is just acting as malicious client. And this Forti client here just acts as a legitimate other user that hasn't been compromised yet. So we're just going to run this stuff. And we can see that the at the end, the XSS was successfully uploaded. So all we need to do, wait just a second, I will also run again what we saw before, the malicious EMS. So now just an admin just needs to visit a simple page, and they will be prompted with an XSS. Now, here is just a message, you don't really need to show any alert, but this also XSS will go ahead and tell this endpoint to go and connect to the other one. So you can see it happens automatically on the background. And now we are basically connected to the malicious EMS. So again, we just need to wait a bit, and then we will see a calculator again. All right. Cool. So we were actually a compromised client. We uploaded an XSS. An administrator visit that page, made every other connection, every other endpoint connect to a malicious EMS, and then we compromised every machine within an organization. And that sounds impactful. That sounds very interesting. But we compromised FortiClient using Electron, meaning that we compromised the renderer process, which is running under the current user. Wouldn't it be nice if we can also use FortiClient to escalate to root? Well, let's see. So again, just a disclaimer, I was researching on macOS. It could be relevant also to other OSs. We just didn't check for that. And as you saw regarding FortiClient, so we have the UI that runs on user mode, but FortiClient is a very powerful software. So it does require root permission from time to time. So for example, installing certificate or scanning for malwares or flushing DNS or whatever. So to tackle this, FortiClient, what we saw, the UI is just the tip of the iceberg. So it actually has many processes. They had many daemons, which is also known as helper tools. And each and every process has its own very purpose. So for example, this EPC TRL is relevant to only the communication with the EMS. Now, all of those processes basically communicate with each other using XPC, which is the Apple way of saying IPC. And what is important to know here is that a process can basically register itself as a server or as a listener. So that means it will expose certain functionalities, and those functionalities could be sensitive. So for example, if the process is running under the root and it exposes some functionalities that require root, it could be sensitive. And regarding the client, every actual process can act as a client. Every process can see what services, XPC services are registered, and it can just try to invoke any XPC request. So that means it's the responsibility of the server to actually verify, authenticate, and authorize the client. And this can be done using a code signature. So every executable in macOS is required to be signed. And you can also most commonly see that XPC services take the team identifier part of the signature. This one will basically identify the developer, so that way I can be certain that the client is a client that I have developed. And also I can be sure that nobody has tampered with it because it's signed. Okay, so we went ahead and tried to look at how actually FortiClient verifies, how the XPCs FortiClient have actually verifies the client. And we started with the should accept new connection, which is the general handler of XPC services. And then it goes ahead, it takes the process identifier of the other process, of the client, and it checks the isValid PID, which takes from that PID the path of the executable, and then it goes to verify signature, which basically from that path extract the actual signature of that executable and compares it in hard code to the actual team ID of FortiNet. On paper, this looks fine, I guess, but there is a race condition here. Basically, we can create a PID, a malicious executable. We can request some XPC invocation of some sort, But while it gets the PID, we quickly switch our executable to a FortiNet one. And then if the race condition is successful, only after it will get the actual executable of that PID, and the verification will just follow through. And this vulnerability is named PID reuse, but it doesn't directly cause any impact. It means that we can invoke arbitrary XPC functions, but we're dependent on what the XPC functions are, actually. So from here, we can take all the XPC listeners of FortiClient, and we can reverse engineer the protocol. You can do that in Ghidra, but more simply, you can use class dump, a third-party tool, to basically dump all the objects of this binary. And then you can find this service protocol object, and we can list all the actual functions we can invoke. And throughout the all XPC listeners, there was one that was very interesting, and one function that was named run tool. And this run tool is actually multi-purpose function. It has a switch case, and according to what you give it, it has like many application logic that it can do. And we found that if you give it ID 11, it goes to this quart resorter file, it's supposed to be restore, which basically reads a file that you give it, creates a new file, does some kind of magic, and then writes a data to the new file, changes its owner, permission, and deletes the first file. Looks very weird, but once we know what feature it's actually relevant to, it's quite understandable. So this is actually it's actually following the quarantine file feature. So if FortiClient scans your computer for malwares and it finds like a malicious file, it will quarantine this file, it will move it to quarantine sandbox folder, and it will basically change everything. It will change the file name, the content, the permission, the owner, basically making this file quarantine, not accessible, not executable, and yeah, this is a common practice that we see in IT viruses and stuff like that. But that means that in the new format, all of the original, or most of the original data and metadata is saved in that new file format, in this quarantine file format. And what we saw before, this XPC request is actually unquarantines this file. So we send it a file name. Here it's a quarantine file. It will go ahead to this sandbox folder. It will search for this file, and it will basically restore it to whatever destination you requested to do. So can we create a fake quarantine file and overwrite whatever we want on the machine? Not so fast, because the quarantine sandbox folder does require root access, so we cannot write to there whatever we want. But of course, conveniently, we can traverse back and point to whatever file we want. So all that is needed to do is just like reverse engineer the file format, create a small script that actually creates a file format, a fake quarantine file, and then we have a root arbitrary file write. So from here to actually execute code as root, you have many options. We chose the route of overwriting the periodic daily file, which executes daily as root. Now let's see it in action. So this is currently the file. As you can see, this is the default one. And here I'm just going to see who am I. I'm user. So let me just create a reverse shell listener. And here you can see that currently there is no temp.txt. That means that we just need to create this file. This is the fake quarantine file, as you can see here. And then we just need to run the race condition LPE. And basically you can see also that the file got deleted, the fake quarantine file got deleted. And we can see that the periodic file got actually rewritten. So now to actually execute as root, we can either wait for it to execute daily, or we can just like do it on purpose. So this is just for demonstration purposes. You can also just wait, and then it's supposed to. Does it work? Of course, it doesn't work. Yeah, just imagine you have here root, and yeah, fine. Thank you. All right, so we basically compromised every machine within an organization. Not only that, we also escalated to root on macOS. So yeah, after I reported everything, this was me on a call with our IT department. I was quite happy, you can see, because we realized that we can either wait for FortiNet to fix it, or we can delete it from my computer. Yeah, so going over to disclosure and summary. Here it's a little bit funny. I will just say something good first about FortiNet. They are independent, they handle the issues smoothly overall, and internally it's like, yeah, they publish, they assign a CV, it's quite nice. They're also responsive, which is always appreciated. But regarding improvements, first of all, after we disclosed all the vulnerabilities, we started getting some marketing mailing list. So apparently they added us to their marketing mailing list, which this is a first for me, but okay, this is not the worst part. They still didn't fix everything. It has been more than half a year, so there are some bureaucracy included when reporting vulnerabilities. But what we've seen today was all fixed. And also their CVSS scoring is off. Let's see an example. You remember this one-click RC that we saw at first for FortiClient? Yeah, they gave it CVSS low. And they say, we only consider a scenario where you have malicious admin that can execute arbitrary JavaScript, completely neglecting the fact that from JavaScript you can execute arbitrary code, and I can send a link, and then I don't need to be a malicious admin. They say, we tend to avoid social engineering as possible scenario, and they can do it, according to them, because there is some protection mechanism that is enabled by default, which warns user if they try to connect to an EMS with an invalid TLS certificate. They are correct. It does exist, this protection mechanism. But this protection mechanism warns user that try to connect to an EMS with an invalid TLS certificate. We basically told them, yeah, everybody can get a valid TLS certificate, and they said they're going to check it. Didn't come back to us since then. Next was a 2-click FortiClient RCE. This one required a little bit of more user interaction. They gave it medium, but interestingly, they give all the impact score a low. They say it's low because it's executed as user privileges. Well, you might say as well that root is low because it's not kernel, or kernel is low because of physically executing you, whatever. But yeah, it's just off. So again, also EMS XSS, only the integrity here was low because they only consider the limited arbitrary file write. They don't consider the subsequent XSS or maybe DOS if you write a huge file or whatever. So yeah, it's kind of a narrow type of view. All right. So let's take some takeaways from this research. First of all, if you are customers of FortiNet, do not underestimate low impact bugs. If you can update and patch something, go ahead and do so. Also, endpoint protection at the end is just a software, like any other software. And it can have bugs and vulnerabilities. And we've seen it in the past, like threat actors that use endpoint protection and antiviruses to actually facilitate their attack on an organization. And in fact, when you think about it, it's also a double-edged sword, because as an attacker, you are certain that every endpoint within an organization is actually using this software. So if you have a vulnerability there, it could be very impactful. So with that, thank you all for listening, and yeah, we have some time for some questions.
Are there any questions? Are there any questions?
Hey, good talk, thanks. No question from my end. I just wanted to let you know that it didn't work because you had a typo.
Oh.
You didn't wrote daily. There was a T inside, and that's why it didn't work.
You are correct. Thank you.
You're welcome.
Are there any other questions? Yeah,
Fine.
thanks again for this great talk.
Thank you for listening.